Okay. So let's today I'm going to study linear equations involve more than one variables. So we call it a system of linear equation. You need 2 or 3 equations to determine the value. Okay. So there are 2 let's begin with the following. I suppose a linear equation, right? And if you just only one equation, this is the equation in 2 variables. Okay, it's a linear equation. You don't see squares. You don't see radical. Okay, so this is called linear equation. But clearly, this single linear equation do not determine the values of x and y uniquely. You have lots of solutions here. Okay, for example, when x equals 1, then you get a y value. When x equals 2, you get another y value. Okay, so there are. However, if x and y satisfy another equation, for example, then more likely you can get unique values for x and y. Okay, so we try to find x and y satisfying these 2 equations. I do not say that you can always get a unique values for x and y. Sometimes you have no solution. Sometimes you possibly get infinite many solutions. But in general, you are only going to get unique solution. Okay, 2 equations, 2 variables. To solve this problem, to solve this 2 equations, I am going to label these 2 equations, equation 1 and equation 2. All right. The method I'm going to use is called elimination method. Right, elimination method. How to eliminate? Yeah, we're trying to eliminate one variable. Then you get an equation in one variable, right? Okay, then you can always solve that equation for the remaining variable. And then once you get either x or get a y, then you can determine the other variable. All right, so what I'm going to do here, I find out, I look at those 2 equations. I notice that the first equation is negative y, second equation is y. So if I add them together, the y will be gone. So let's try. So equation 1 plus equation 2. So the left-hand side, 2 terms on the left-hand side, I added them together, right? So it'll be x minus y plus 2x plus y. And then here, negative 3 plus 1. All right, so minus y plus y, they're gone. So you get 3x. Right, you get 3x. Right. So you get 3x on the left-hand side. So we eliminate this variable at y. And the right-hand side is negative 2. Then from here, you solve for x, it's negative 2 over 3. So it's a fraction, it's not an integer. Then you can use any of the equation to get y. For example, by the first equation, right? And what is y? I think y is going to be, y is going to be, x plus 3, okay? Right, you move y to the right-hand side, you move negative 3 to the left-hand side. So x, you already know the x value. So you can add them together. So it's 9 over 9, and 3 over 9, and 9 over 3, right? So then you get 7 over 3. Right? You get 7 over 3. So that is the answer. Okay. So you get x value, you get a y value. If there's no competition mistakes, and this, yeah. And this, you get two values. One is for x, one for y. So there are only 2 numbers satisfying these 2 equations. Now, another method we call substitution. Okay, I'm going to show you how to do this, use substitution. So hold on. So x minus y equals 3, right? -3. So 2x plus y equals what? That's equation 1, that's equation 2. Okay. So the next method, we call it substitution. Right? Substitution. So by the first equation, I solve for x. So you move y to the right-hand side, and this y minus 3. Okay. Then I plug it into equation 2. So in the place of x, I put y minus 3. Okay. Plus y equals 1. So I get 2y minus 6 plus y equals 1. So 3y minus 6 equals 1. So I move 6 to the right-hand side, it becomes 7. So 6 plus 1, 7, right? So then you divide by 3 on both, I get 7. So you get y first. Then you can put back this equation. Any of the equation is fine. Then x equals y minus 3, so 7 over 3 minus 3. So combine them, it's going to be 7 minus 9 over 3, so it's going to be negative 2 over 3. Okay. So that's two different ways to solve the same problem. And you should be able to get the same answer. The second method called substitution. The first method called elimination. Sometimes it's mixture. Sometimes some steps you just add 2 equations. Sometimes you use a substitution. Okay. It's up to your choice. You know, the second question here. X minus 2y equals 9. So x plus y equals -5. Right? So those 2 equations, we try to solve it. Now, equation 1, equation 2. I think we can use a substitution. Okay, we can use a substitution. By equation 1, I get x equals 2y plus 9. Right? Right? You move 2y to the right-hand side, and then you plug it into equation 2. So it's 2y plus 9, that's x, and plus y equals -5. You get 3y, right, equals -5 minus 9, it's -14. Okay, then you divide both sides by 3, it's -14 also. So the very last step, you get the fraction. Right? There you get fraction. So then you use this identity, right? Then this one, you know, x is going to be 2y -14 over 3 plus 9. Okay. So it's going to be 28 over 3 plus 9. Plus 9. 9 is 27. 27 over 3. So the answer is -1 over 3, right? 28 minus 28 plus 27. All right, so we get 2 answers. Now, if we really want to do elimination method, okay, so we can, we probably can do that. And then you have to be, then you have to be careful, when you add the equations. Equation 1, it's not necessary to add them together, sometimes do subtraction. So how do you eliminate them? If you just add them together, you don't get rid of x, don't get rid of y. So there are a couple ways to do, okay? The first method is use subtraction, just equation 2 minus equation 1. Okay. Then you can get rid of x because the left-hand side minus x minus y, right? So right-hand side, -5 minus 9. So then you immediately get rid of x. So here you got x plus y minus x plus 2y. And this is -14. So what you get here is you get 3y equals -14, y equals -14 or 3. Right, then you can use any of the equations to get, let's use the second equation to get x. X is -y minus 5, right? And -y, so it's -4, negative. So let's figure it out. Okay, 14 over 3 minus 5. 14 minus 15, so it's -1/3. So we get same answers, just different approaches, right? Is there any other way to use elimination method? I'm going to show to you. Yeah, this is a good problem, Another, can I still use addition to eliminate one variable? If I just add 2 equations, I'm not able to get rid of that if I add them together. And I wish the second equation has 2y there, right? But unfortunately, just only y. So what I'm going to do is, if you don't want to use subtraction, I multiply equation 2 times 2. So I get 2x, 2y, -10. That's called the equation 3. Then you just work on those 2 equations. You modify second equation. Okay, so you get equation 1 plus equation 3. Then you get x plus 2x plus 2y and the 9 plus 10. So xx, y gone. So 3x is going to be -1. So x equals 1 over 3. Okay. Yeah. So you get x. Then you can use any of the equation, get y. So you can say by equation 2, and then y equals -5 minus x, -5 minus -1/3, and then -5 plus 1/3. Then add them together, and -15 plus 1 over 3. So it's -14 over 3. So it's the same answer. All right, so I even elimination method, I show you 2 different ways to do. And this problem can use any of these methods. All right, I'm going to ask you to solve the following problem. You can use any of the methods, okay? And give me the answer, okay? If you get it. Okay, remember we have 2 different methods, right? Elimination method and like substitution method. All right, please take a piece of paper, pencil, and work on this problem, okay? I want to get answers from you guys, each of you, not only get answer from Rebecca. I know she always gives me the answer quickly. I want to get answers from Jessica, not okay, Ivan, Erica, okay, Emma, Edward, Daniel, Angela. Yeah, it's better to use a fraction. Okay, it's better to use a fraction. Yeah, instead of decimal point. I think Erica's answer is correct. All right, good. So maybe your approach is different from mine. That's okay. I see. I'm going to use the elimination method because I see negative y, positive y that can be canceled out quickly. So I add them together as a 5x and then get 6. Right? 2x plus 3x, 5x. 1 plus 5, 6. So x is given 6 over 5 immediately. Then let's say by the first equation. So y equals 1 minus 2x. So 1 minus 2, 6 over 5. Okay, it's going to be 12 over 5. This will be 5 minus 12 over 5. And that will be negative 7 over 5. Okay, keep it a fraction. Okay, Erica, keep it a fraction. Okay, don't change it to the decimal numbers. Okay, fraction is best because sometimes you are not able to get a terminating decimal number. Okay, just like 1/3, you cannot. It's better not to write the 0.3333. Okay. So our next problem is going to be 2x plus 3y equals 13. 3x plus 2y equals 12. Now, what is the best way to solve this problem? I find out neither of the elimination method or the substitution method are not good. Because if you substitution method, you have to solve for x in terms of y, then you get a bunch of fractions. If you use the elimination method, you cannot eliminate the variable directly. You probably have to modify, and then it's not trivial. Okay, I'm going to show you how to use the elimination method, but substitution method definitely is wrong. It's not a good idea. What I'm trying to do is, I just add. I do not eliminate the one variable, but I make this equation simpler. So add those two equations together, I get 5x, 5y equals 25. Okay, if you both sides divide by 5, I get 5. So x and y both, if you add them together, you get 5. So you get a much simpler equation than any of the previous equation. Okay, then you can use a substitution. You can use you can use a substitution. You can also use a elimination method to eliminate the variables. But if you want to do elimination method, you have to multiply equation 3 by 2. Okay, and that's the equation. Then you can use that one to get rid of the y variable. Okay, but I'm not going to use that. Okay, what I'm trying to do is I just solve for x in terms of y. Okay, then I plug it into any of the above equation. Plug it into equation 1, equation 2, really doesn't matter. Okay, let's do equation 1. Okay, 2x, 5 minus y, and 3y equals 13. So let's multiply this out. 10 minus 2y, 3y equals 13. So 10 plus y equals 13. Y equals 3. Am I right? Yeah, y equals 3. Okay. Y equals 3, then x is clear. X is going to be 5 minus y, 5 minus 3, that's a 2. Okay, I do have some students finish that. Okay, so you do, you add the two equations together, you simplify the equation, but still involve two variables. But you can use that to use substitution. Okay. Now, if you really want to use a elimination method, what are you going to do? You want to eliminate one variable, right? So I want to make coefficients in front of x the same. So what I'm going to do is equation 1 multiplied by 3, equation 2 multiplied by 2. So I get 3, right? 3 times 2, 6. 3 times 3, 9. And 3 times 33 is 39. And here 3 times 2 is 6. And 2 times 2 is 4, 1. 12 times 2 is 24. Okay, so that is equation multiplied. Okay, so now you can do subtraction, equation 1 minus equation 2. So 6x is gone. 9 minus 4 is 5y. Okay, and then 39 minus 24 is 1 and 5. So that implies y equals 3. So if once you get to 1, then you can use the annual equation to get x. Okay, it's 2x plus 3y equals 13, right? So 2x equals 13 minus 9, which is 4, and x is 2. Okay, x should be equal to 2, right? All right, so that's called the elimination method, and it still works. All right, so the next problem is from math cards. All right, 776x plus 77y equals 775x, 77x, 778y equals 776. Please, yeah, try this for yourself. I hope you can figure out how to do it. All right. Now, this is 7, right? So those are very big numbers. And if you want to use a substitution, solve for x, it involves fractions. We don't want to, to have too many fractions at the very beginning. Any idea, Rebecca? Yeah, I let you to try, okay? I give you a minute. to think about. Hey, so let's see. I do see someone gets answers. Great. So I just go ahead to add those two equations together. Okay. Or do add or subtraction. Okay. If I add so I look at the difference. Okay, the coefficients. 776 now 777. 777 and 778. But if I add two equations, I don't think it's a good idea. Yeah, I do the subtraction. Okay, I do the subtraction. So equation 2 minus equation 1. Then 777 minus 776 is just x. 7778. Yeah, 778 minus 777 is just 1. And that's 1. See, this is wonderful. It's a very simple equation. Okay. Then the next step is quite simple. So you solve for y, then you plug into any of this equation. Okay, equation 2. So 77x plus 778, 1 minus x equals 776. I hope I can get a simple x. Okay, not too bad. All right, so you will see that this will be 778 minus x 776. Okay, so x is going to be 778 minus 776. That's going to be 2. So if x is 2, then y equals -1. Okay, so 2 and -1 is correct answer. Daniel, good job. Okay. Now, if you definitely substitution is not good. Now, if we add the two equations together, I don't think we are able to get simplify the equation. So subtraction is the only way you can go. Okay. Otherwise, you have to deal with the very large fractions, okay. Very complicated fraction numbers. Okay. Now let's take a look at the new type of equation. So x to the y equals 3 to the 2. And 3x minus 7y equals 5. Okay. How do you solve this type of equation? Now, this equation is equivalent to x over y equals 3 over 2. And that's also equivalent to 2x equals 3y. Or just 2x minus 3y equals 0. So then it doesn't matter, right, which equation we use. Okay. But it's harder to get rid of the one of the variables. Okay. So what is the best way? Actually, we should use the original equation to solve, because x and y are right, is proportional to 3 over 2. So you can introduce a new variable. That's a trick. Okay. So it's going to be 3t y equals 2t. So solution to the first equation is going to be, yeah, there's some parameter here. Okay. Then x to the y is going to be 3 to 2. Now use this equation, plug it into the second equation. So 3x is going to be 3 times 3t. And the 7y is a 2t here equals 5. So I get a 9t, 14t equals 5. And that will be negative 5t equals 5. T is going to be negative 1. Okay. If t is going to be 1, then you get x and y. Very simple. If t is negative 1, right? If t is negative 1, then x is 3t, y equals 3t. So you can write down the answer. X is negative 3, y equals negative 2. Okay? Yeah, you can put it into here, right? Okay, that's so whenever you see the ratio in the equation, and you're trying to introduce a new parameter, and then determine the new parameter using another equation. Right. Now, there's some equations at the very beginning does not look like a linear equation. How do you solve this equation? How to solve this system of linear equations? Those are not linear equations, but either you introduce a substitution, you can let 1 of x to be u and 1 of y to be v. Okay, then you get system of linear equations. Or you just simply write the equation 1 plus equation 2. And 1 of y is gone. So 2 of x, 1 minus negative 1 plus negative 2 is negative 1. And from here, x is going to be negative 2. And once you get a negative 2, and you can get x. Okay, then you can use any of the equation 2, right? 1 over y equals negative 2 minus 1 over x. Negative, yeah. So it will be negative 2 plus 1/2. And negative 4 plus 1 is negative 3. So you get x and you get, no, the y is not done yet, right? So 1 of y equals that. So y equals negative 2 over 3. Right, so this is answers. Now you can also use a substitution. Yeah, let u to be 1 of x, v to the 1i. Then you find the u and the v. So u minus v equals 1, u plus v equals negative 2. So once you solve for x, then solve for y. Once you solve for u and the v, then you can get x and y because that's just a reciprocal, right? So you can, actually it looks better if you do like that. So equation 1 plus equation 2, 2u equals negative 1, right? U plus u, and negative v, positive v cancelled out. And the u equals negative 1/2. Okay. Negative 1/2, yeah. Then you can also use, the end of the equation. You can also do subtraction here. Okay. But let's use the second equation. So v equals negative 2 minus u, negative 2 plus negative 1/2. Right. So that will be negative 2 plus 1/2, negative 3 over 2. So you get u and the v, but x is going to be, right? X is going to be u, right? So it's going to be negative 1 over 2. So that implies x equals negative 2. And the y is going to be, this is going to be 1 over y. So that implies y equals negative 2 over 3. Okay. Yeah, so there's some equations at the very beginning does not look like a linear system linear equations, but you're still able to solve it. You can use a substitution to solve it. Right, so let's take a look at this brand new type of problem. Okay. We have two equations. We want to find out x plus y. So you're not asked to find the individual value of x and y, right? But you just need to find x plus y. In this case, you probably don't need to find the individual value, the value of the individual variable. Okay, you can bypass that part. Of course, sometimes it's very easy, quick way to find x and find y and add them together. So this particular problem, maybe we don't need to do that. Okay. We don't need to find the individual value of x and y, add them together. How do you do that? Okay, let's try equation 2 minus equation 1. So I get 4x minus 2x is 2x. Y minus negative y is 2y. So that is 2. Then clearly xy plus 1 equals 1. Then x plus y equals 1. Yeah, good job. Right? But if you're trying to find the x and the y, it's possible, but it's better way to do is to use this x plus y, okay, to solve. If you use substitution, yes, you can find the x first, but we don't want to do that here, okay? We just want to find the x plus y. All right. Now we already learned two variables, right? Equations in two variables. Now how about equation in three variables? So idea is similar. We have to do step by step to eliminate one of the variable. Okay. Then you get equations of two variables. You get two equations, two variables. Then you find those two variables first. Then you go back to the third variable. So I think the idea is that we use a substitution here to get rid of one equation, one variable, yeah. Or use the elimination method to get rid of one variable. So how can I do that? I'm going to do the following, okay? I'm going to use the elimination method to get rid of one variable, x. Equation 2 minus equation 1. So x will be gone. Y minus negative 3y is a 4y plus 2z. Okay, negative 2 minus negative 10 is going to be 8. Okay, so simplify a little bit, you get that equation. Okay, so we keep it. Okay, I call it maybe 2 prime because it's modified. Then equation 3 plus equation 1. And then x is gone. So 2y minus 3y is negative y, right? And negative 10 plus 5 is negative 5. Okay, or you can y minus z equals 5. That's equation 3. So now you get the two equations with two variables in two equations in two variables. Okay, so we continue to use the elimination method because I see that it's positive y, negative y there. So So add them together, it's again 3y, z is gone, it's 9, so y equals 3. So once you get the y, then you can get z. You can get a z, let's say 2 prime. Okay. So z is 4 minus 2y, 4 minus 2. Y is 3. So you determine the variable z. Right. Finally, we can use any equation to get x, right? By any of the equation, doesn't matter. The first equation looks simple. X equals 3y minus 10. So by the first equation, x is 3y minus 10. So 3 times y is 3 minus 10. So it's -1. Okay, so we get all the, we determine all the variables here. For system of linear equations, 3 variables, there are really multiple ways to eliminate the variables. Okay, I just suggest to give you one of them. All right, let's take a look at this one. It's really complicated now. Two x minus 4y minus z equals 14. All right, so we have 3 questions. We don't know what we can get. Right. I'm going to either solve for z from equation 3 or solve for x from equation 1. So x is 2y minus 3z minus 7. Okay. Okay. Right. Then you put it into this equation, put it into that equation. So you can get rid of the x. So 2y minus 3z minus 7 plus 2y plus 5z equals -13. Let's simplify this. 6y minus 9z plus 21 . Okay, let's simplify it. So 6y, 2y, 8y minus 4z plus 5z is minus 4z. And 21 is moved to the right-hand side. 21 minus 13, right? That is 8. So this equation, if you divide by 2, you get equation like that, okay? So maybe we should call it 2 prime because it's come from 2. Okay. Okay, so now let's plug it into the second equation. Okay. So the idea is that you solve for one variable, solve for x, and express it in terms of yz and plug into the other 2 equations. So you got 2 equations and 2 variables. But as you can see that we have to be very careful when we do the computation. Otherwise, you will get the wrong answers. Okay, so y here, y is gone. I'm surprised. And z, negative 6, z minus 14 equals 14. Now here's another z there. So minus 7z. So I think z is negative 4, right? So you get the equation. Now, sometimes you're lucky, you just don't have it. You only have one equation here. So then you put it here, you can solve for y, okay? 2y minus negative 4 equals 2. So 2y equals negative 4 plus 2 is negative 2. So y equals negative 1. So you have these two values for x, z, y, z. And then you go back to the equation, right? Then you use the first equation. So you get x, right? X is 2y minus 3z minus 7. What is it? Z is negative 4. Okay. Okay, let's see what do we get. I think it's going to be 3, right? Yeah. So x is going to be 3. I think if you use a different approach, you will end up with the same answer. Okay. X equals 3, z equals 4, negative 4, y is going to be negative 1. Okay. All right, now let's take a look at it as a very strange equation, 3 variables. So x over 2 equals y over 3 equals z over 4. And x plus y plus z equals 18. Now, how many equations do we have here? We actually have 3 equations. The first equation here can be broken into 2 equations. Okay. I'm going to let you try, okay? I'm going to let you try to see if you can able to get it. Okay. Then I will discuss after you give it a try. I know this is a new question, right? You never see before, but there's so many things you never see before. Will you be able to figure it out? Find a way to solve it. Okay. We'll try. Okay, give me one or 2 minutes, okay? I say essentially you still have 3 questions here, although it's just written in 2 equations, because the first equation has 2 equalities. So anyone has an idea? All right. Wow. Evan got answers. Great. All right, so let me show you, okay? Now, the first equation is strange, right? So we can let x over 2 z over 4 to be t, okay? So then you have the first equation get 2t, y equals 3t, z equals 4t, okay? So if you, the first equation implies x to y to z is a 2 to 3 to 4, in other words, okay? i.e. x to y to z is going to be 2 to 3 to 4. And sometimes the equation can be written in this form. Okay. Right? Then you use the second equation, 2t plus 3t plus 4t equals 18. And so 9t equals 18, t equals 2. Okay. If t equals 2, then you can quickly get x equals 2 times 2, 4, y equals 6, z equals 8, 4, 6, 8. Okay, so this is the quickest way to solve the problem. Now, what happens if we do have only have two equations? Okay, we know, yeah, we only have two equations. Okay, we assume that, yeah, find the x of y if y is not equal to 0. Okay, if y is 0, you cannot find the ratio. Okay, how do you do that? Can I determine x and y? Sounds like it's impossible. Otherwise, I don't need to assume that if y is not equal to 0. Maybe I have more than one solution there, a multiple solution, right? So this is also a brand new function equation. We only have two equations here, but they have three variables. Okay, I don't think we are able to completely determine the values of each variable. Right? How can I do that? Well, since we are going to find the x and y, so why not just solve for x and y? Okay, just solve for x and y. And then say, well, there's z there. Well, don't worry about it. Z is just a number, some number. So I get 4z and 2x minus y equals negative z. So that's the equation 1, equation 2. Well, how can I cannot eliminate two variables. I can multiply the second equation or the first equation by 2. So get 2x, 4y equal 8z. Okay, that's one prime, right? You multiply each term by 2. Okay, then I do the subtraction, equation 2 minus equation 1 prime. So 2x is gone. Negative y minus negative 4y. And here negative z minus 8z, okay? Yeah. So I get 3y equals negative 9z. So I get y equals negative 3z, okay? So y is negative 3z. Then you can get x by the first equation. X is going to be 2y plus 4z. 2y, y is negative 3z. Okay, I get negative 6z plus 4z. So it's going to be negative 2z. Okay, so now each of them I express in terms of z. So if I want to find x over y, I just put 2z here and the negative 3z over there. And the z cannot be 0 because y is not 0. Y is not equal to 0 means if only if z is not equal to 0. So that makes sense. Okay, so then you get only with 2 over 3. So x and y are the proportional, but you don't have, yeah. Actually, you can get a family of solutions. You can think about, right? Remember, x equals negative 2z, y equals negative 3z, right? How do I describe those? And how about z, right? I didn't even mention z, right? Okay. So I can let z to be some t, okay? Then x is going to be negative 2t. Y is going to be negative 3t. So t is arbitrary parameter. So you can express it in the form x negative 2t, y equals negative 3t, z equals t. Okay. So t is arbitrary. So you have infinite many solutions. Infinite many solutions. Okay. And t is arbitrary. Okay. So you can let t to be 1, 2, 3. You can always get a triple numbers, which are solutions. Okay. Yeah. So even from here you can find out. You can even find out, yeah, x to y to z. So you get a negative 2, negative 3, and 1, right? So if I ask you to find this ratio, then you get this number. Okay. So if I add the additional condition, then if x squared plus y squared plus z squared equals 1, then you can almost determine the value, okay? Then you will see negative 2 squared, negative 3t squared plus t squared equals 1. So I got 4t squared, I got 9t squared, I got 1t squared equals 1. And I have 14t squared equals 1. Then t squared equals 1 over 14. Okay. So t is going to be plus or minus square root of 14. Okay. Then you determine two sets of negative 3, negative 2, right? So two sets of solutions. T equals negative 2. I keep forgetting. Negative 2 square 1 over 14. Y is going to be negative 3 square 1 over 14. Z is going to be 1 over square 14. This is one set of solution. The sum of the squares is going to be 1. Another set of solutions is going to be plus 2. Okay. So what is the geometry meaning of that? The geometry meaning of that, I'm going to talk about, if this is usually means a line in the space. So this is, that's. So x equals negative 2t, y equals negative 3t is equal. It's actually, it is going to be like a strict line, okay, passing through this. Passing through the origin. Then you have two intersection points on the sphere, okay? And those are the coordinates of the points. Okay. So when you study more advanced geometry, 3D geometry, and you may have to find the intersection points of line with the sphere, find the coordinates in the space, something like that. Okay. So anyway, we just needed to learn to this point, find the ratio or find the, x over y or y over z or z over x. Okay, if we are only given 3 questions in x, y, z. All right, so let's stop here, and I wish you have a good weekend.